All right, so we're going to go through and talk about this. We're going to talk about how to solve these problems, how to figure out the answers to them. Again, for the test tomorrow, I will have all of the equations in for you, and I'll have them all balanced for you. So you just need to figure out where to put the different parts of these. So here, remember that the only thing that can go in this table is moles. They've conveniently given you for the first one the moles for the equation. So here, I'm going to find what this is. This is magnesium, and I'm going to put that in here under the magnesium. So that is my moles of magnesium. They've told me that my chlorine is in excess, and before I start the problem, I'm not going to have any of the magnesium yet, or magnesium chloride. I need to figure out what my cloud number is going to be. So I'm going to take that. I'm going to go up into the cloud here. When I go into the cloud, what operation do I perform? Division. When you go into the cloud, you divide. So this divided by 1 is 3.56. When I come down out of the cloud, then I'm going to want to do what? Multiplication. So I'm going to come down, I multiply through the coefficients to get to the next line. So this is going to be subtracting, because we're using the reactants up to form the products. So 1 times 3.56 is 3.56. 1 times 3.56 is 3.56. And here it's going to be a positive because this is the stuff we're making, and that's going to get multiplied by 1 as well. So this is going to have nothing left over. We'll have an excess amount here, and here we'll have made 3.56. What are my units on here? What's the only thing that goes in the table? Moles. So I've got 3.56 moles of the MgCl2. I need to multiply that by the molar mass for magnesium chloride. So I've got to figure out what that molar mass is. So I'm going to take 1 magnesium off the periodic table. That's 24.3. I'm going to take 2 chlorines. 2 times 35.5 is 71. And I add those together. So that's 95.3. So I'm going to multiply this by 95.3, and that's going to give me my grams of MgCl2. And that is 339 grams of MgCl2. Making sense? Any numbers here that I have written that you don't know where I got the number from or how I got it? Okay. All right, the next one here, they've given us grams. Can I put grams in this table? No, I can only put moles in the table. So I need to take this value and I need to divide by the molar mass. So I've got 8 times 12. 8 times 12 is 96 plus 18 hydrogens. That's 114. So I'm going to divide this by 114. That ends up being point, and you need to have 3 sig figs in this table. So 0.724. I need to have 3 sig figs in here when I start. This one, they told us it was excess, and we don't start with either of these. Questions there?
I have 1.38 for number 1.
1.38 here?
Yeah.
So 82.5 divided by 14. So 12 times 8 is 96 plus 18. That's 114. So 82.5 divided by 114, that's 0.724. So I need to get my cloud made. How do I do my cloud? What do I do with my cloud? I'm going to take this number. When we go up into the cloud, what do? Divide. Yes, we're going to divide to go up into the cloud. So 0.724 divided by 2 is 0.362. All right, now I need to come down out of the cloud and use that number for this next line. Remember, we're subtracting from our reactants and we're adding to our products. So when I come down out of the cloud, what operation do I perform with the coefficient? Multiplication, right? So we're going to multiply by all of these coefficients to get to this next line. So this is going to be minus 0.724. This I've got to calculate on my calculator because I can't do that in my head. That times 25 ends up being 9.05. Times 16. I get 5.79 here. And I get 6.51 here. All right, what values, what units are these in? What units are in the boxes? Moles. They wanted to know each product here. So for this product, this is CO2. I'm going to take this value and multiply by CO2's molar mass. I have 1 carbon, that's 12, and I have 2 oxygens that are 32. So that's a total of 44. So I'm going to multiply my moles by 44. So that ends up being 255 grams of CO2 here. And then for water, I have 2 hydrogens and I have an oxygen. That is a total of 18. So I'm going to multiply this by 18. And that ends up being 117 grams of water. All right, what questions do you have about number 2? Anything on number 2 that makes sense to you? Number 3, this is a limiting reactant problem, okay? So, and remember, I gave you this guide here on how to do these. So if you are still struggling with these, go back to this guide. This is in your packet where I've told you step by step. Number 1, write the balanced equation. Number 2, place it in the BCA table. Number 3, If given grams, convert those to moles. I showed you how to convert to moles, okay? Showed you how to calculate molar mass. I showed you how to calculate the number of moles. Then I showed you how to put that in the table and how to divide by the lowest mole value. And then I've done that again here for limiting reactants. So the first thing is convert the mass of each reactant into moles by dividing the grams by the molar mass. Okay, so we're going to go back and do that on here. They've given us the grams. We're going to divide by the molar mass. So for manganese sulfate, one manganese is 54.9. A sulfur is 32.1. And 4 oxygens are 64. So I'm going to add those together. And that's 151. So I'm going to divide 25 by 151. That ends up being 0.66. So that's what I'm starting off with here. Then I need to do the same thing with this barium chloride. So barium is 137.3. And I've got 2 chlorines. That's going to be 71 total there. So this I'm going to divide by 208.3. So that ends up being 0.216. All right, questions on any of those? How I got those values, how I got them where they're at. All right, now I'm going to take both of these up into the cloud. When I go into the cloud, what operation do I perform? Division. So I'm going to divide both of these by their coefficients, which happen to be 1s in this case. So this is 0.166, and this is 0.216. So if I go back over to this sheet where I was showing you how to do this, we put these under our headings. We have 2 clouds now. And the way I did that was I divided by the coefficient to get my 2 clouds. Then I'm going to determine which cloud is the smallest and eliminate all other clouds. So step 4 is determine which cloud's the smallest and get rid of the other ones. So which cloud is smaller here? Okay, so I'm going to get rid of the rest of these. Just get them out of there so they don't confuse me. Now I'm going to use this cloud to come down, and I'm going to multiply by all the coefficients to get down into the table here for the next section. Here I'm going to be subtracting because they're my reactants, and I'm going to be adding because it's my products. They're all, in this case, multiplied by 1. That makes the math easy here. Okay. Any questions on how I got any of those numbers? All right, they wanted to know how many grams of each product. So we've got to figure out that part. So let's go back to our sheet here. It told us to calculate our change and our after. So we've done that. Now it's asked which, they didn't ask which element, they just want us to do the products. So we're going to figure out the molar masses, and then we're going to multiply that by the mole values for each of these. So magnesium is 24.3, and I've got 2 chlorines at 35.5 each. So 24.3 plus 71, that's 95. So I'm going to multiply this times 95.3. That ends up being 15.8 grams. Here, I'm going to multiply this by barium sulfate's amount. So this, the barium is 137.3. I've got a sulfur at 32.1, and I have 4 oxygens at 16 each for a total of 64. So I add these together. 6, 3, 1, 6, 10, 13, carry your 1. So 233.4. So I'm going to multiply this by 233.4. And that ends up being 38.7 grams of BaSO4. Any questions on number 3? All right.
It's really good how you got the start. That's the only thing I struggled with.
The start here?
Yeah, I just go 1 point.
Okay, so let's go back and read that document. What did it say to do here? So first of all, I've already written your balanced equation. So I've already done number 1 for you. Number 2, it says convert the mass of each reactant into moles by dividing by the molar mass. So you have to figure out what your molar mass is for manganese sulfate. This was my molar mass for manganese sulfate. I added together, oh, this is magnesium. This should be manganese. I had that balance wrong. The math still comes out the same, but I guess over here my answer would be a little different. Sorry about that. This is manganese. This should be manganese, which means that answer is going to be wrong because I used magnesium instead of manganese for that. This should be 54.9. That's 125.9. So this would actually end up being 20.9. Sorry. Okay.
So do I just add all those together and then they just divide by?
Yeah. You add all of these together, and then you're going to divide the grams by that value. Yeah. Sign out on the board and take the clipboard pass. Okay. So I do that for that. But then this one, I have to figure out the molar mass for it because its molar mass is going to be different than this because this is barium chloride. So I did barium and 2 chlorines here, and I divided 45 by that value, and that's how I got this.
Okay.
Then I create my cloud. So I take both of these up into clouds, and I find out which cloud's the smallest, and that's the one I want to use for the rest of my problem. Okay, let's try another one here. Hopefully I got this one right. All right. Here we've got sodium. Oh, we've got excess water here. Okay, so again, same start though. Okay, we've got to figure out, we've got to get this turned into moles. So we're going to divide by the molar mass of sodium. So 23.0. So 67 divided by 23. That's 2.91. This, they said excess, and we wouldn't have had any of this to start. So step 1 is turn grams into moles using the molar mass, dividing by the molar mass. Then you need to figure out your cloud. So I'm going to take this up into the cloud here. this is going to go into the cloud, I have to divide by this coefficient to get it into the cloud. So here's my cloud. I'm going to divide 2.91 divided by 2. So that's 1.46. And then I'm going to come down out of the cloud. To come down out of the cloud, I reverse the operation. So I divided to get there. Now I'm going to multiply. Remember, I'm subtracting from my reactants and adding to my products. Questions?
Why is it 1.46?
Because I was multiplying by a 1 here. The rest of these I multiplied by 2.
Oh.
So here I have nothing left. Here I have an excess amount. Here I've made 2.91, and here I've made 1.46. So my next step is that I want to multiply by the molar masses of each of these products so that I can figure out what that is, how many grams we formed. So I'm going to take a sodium, which is 23. I'm going to take an oxygen, which is 16, and a hydrogen, which is 1. I'm going to add these together. And I end up with 40. So I'm going to take this, and I'm going to multiply by 40 to get my grams of sodium hydroxide. So that ends up being 116 grams of sodium hydroxide. This is H2. So I've got 2 hydrogens at 1 each. So that ends up being that I'm going to multiply this by 2. So that is 2.92, and that's grams of H2. All right. The next one is the doozy problem. It takes everything that we learned this whole chapter and brings it into one problem. Okay, you ready? Everybody ready for this one? This is the big one. All right. So let's go back and look and see what this says that we're supposed to do here. Number 1, write the equation. I will have that done for you tomorrow. So we're starting at number 2. Convert the mass of each reactant into moles by dividing the grams by the molar mass. So let's go over and do that. We are dividing the grams by the molar mass. So we need to figure out what the molar mass of silver nitrate is. So silver is 107.9. I have a nitrogen, which is 14, and I have 3 oxygens. 3 times 16 is 48. So that ends up being 169.9. So I'm going to divide the mass by the molar mass. That's what I've told you to do in this, in the directions here. Convert the mass of each reactant into moles by dividing the grams by the molar mass. And that's what we're doing. So we're going to take the grams here and divide by the molar mass. I need to have at least 3 sig figs in this table. So that's going to be 0.0884. I'm going to figure out the moles, the molar mass for iron fluoride. Hi, Mr. Shannon.
Hello.
Got her fixed?
Yep, so you just have to sign into Adobe and stuff,
Okay,
and
perfect.
then Office as well. You just
Okay.
ask you to sign in. So.
Thank you so much.
Yep, and just as long as you sign in here, you can use it at home then too.
Okay.
So.
Sounds good. Thank
All right,
you.
you bet.
All right, so I've got to find an iron here. Iron on my periodic table is 55.9. Chlorine, I've got 3 of those at 35.5. So that's 106.5 if I add all of those together. And now I'm going to add my iron and my chlorine together to get that molar mass. This ends up being 162.4. So I'm going to take this and I'm going to divide by 162.4. So that ends up being 0.230. Anybody not know where I got some of these numbers from or how I got these values in the table? All right, so let's go back to our instructions and see what it tells us to do next. So we're going to record those in the BCA table. You have not made any products yet, so record 0 for the mole amounts. So I'm going to go and I'm going to record zeros here and here. Now let's see what we've got going on. And it tells us for the next one, we will have 2 clouds now instead of 1 because we don't know which reactant is in excess yet. Divide the mole amounts of each reactant by their coefficients and record those as your clouds. So we're going to go back over here. I'm going to take this and I'm going to go up into the cloud. What operation do I perform? Division. So I'm going to take this number and I'm going to divide by 3. I end up with 0.0295. I want 3 significant figures here. Then I'm going to do the same thing here. I'm going to take this up and I'm going to divide by its coefficient. And this ends up being 0.230. Okay. So now we're going to figure out, we've got those as our amounts. Now we're going to read next. Determine which cloud is the smallest and eliminate all the others. So which one's smaller here? This one or this one? The left one. So I'm going to get rid of these so that they don't confuse me. And now I'm going to use this cloud value to figure out my change amount. So my instructions tell me, if I go back over here, proceed as shown in the previous lesson. So that would be back up here. When we're doing these, it says we're now going to fill in the change line. We're going to use up the reactants so they get subtracted, and creating products so they get added. The cloud amount is multiplied by the coefficient. Okay, so let's go back over here and do that. So I am going to subtract from my reactants, and I'm going to add to my products. Now I'm going to use my cloud and my coefficients to determine what numbers belong in here. So for this one, I'm going to take my cloud value and multiply by 3. Here, I'm going to take it and I'm going to multiply by 1. Multiply by 3. And multiply by 1. I will then go through and I will subtract what remains. So here, this ends up being 0. This, 3 minus, ends up being 0.201. And then I will form these amounts. Any questions on where I got any of those numbers from? All right. Now I'm going to figure out the mass of the precipitate. I will tell you on the test which one of these is the precipitate. So this guy is the precipitate. I'm going to tell you which one is the precipitate by having an S here for solid. They want to know the mass of that precipitate. So I'm going to take, what does it tell us? How does it tell us to get mass off of here? So let's go back and read our instructions here for how to get mass. So it says you will be asked which reactant, we'll get to the excess reactant. Right now we're doing this one. So calculate the amount of products by taking the molar mass and multiplying by the moles in the table. So I need to figure out the molar mass and multiply by that mole amount. So I've got to figure out the molar mass of AgCl. So Ag is 107.9. Cl is 35.5. So I'm going to add those together. And that's going to give me 143.4. So I'm going to take this and I'm going to multiply it by 143.4. That ends up being 12.7 grams of AgCl. All right. So I answered C here. I guess I kind of jumped ahead of myself here. So that's 12.7. What was the limiting reactant? There's 2 ways to know what the limiting reactant was. Which prevented us from making more stuff? Which one of these things prevented us? The first one, right. It has a 0 value here, and it was the one that we used for the cloud value. So that is AgNO3. They wanted to know how many grams of the excess reactant we had left over. So this is our excess reactant. We're going to take that and we're going to multiply by our molar mass for iron 3 chloride. We figured that amount out right here. So I don't have to recalculate that. It's already done. So 162.4 is going to come down here. And that ends up being 32.6 grams. So 32.6 grams. All right. Now, last part of this is the percent yield. We actually made this much. We made 10.2 grams. We were supposed to have made this much, 12.7. We're going to multiply that by 100. So we're going to divide what we actually made by what we should have made, and then multiply by 100. And that is 80.3%. And that's how you do a percent yield. Remember I talked to you about my chocolate chip cookies? So this is 80.3%. Okay, questions? And that's your test. Your test tomorrow is pretty much just like this. I have changed like what the reactants and the equations are. I've changed the amounts that you start with, but it's the exact same wording for the questions. I have taken it from 5 questions down to 4 because we have 40-minute classes tomorrow. So I did remove one of the questions off of here, but it's not this last one. I will tell you, you're going to have one just like this. So be ready for that. Okay?